Good afternoon. So this is Ronan Baron, and I am discussing today Alphasense releases a zero-bias lead-free galvanic oxygen sensor, a drop-in replacement for lead oxygen sensors. So I just want to give you a bit of context. So lead sensors are, as you know, all lead sensors are a very vast majority of the oxygen sensor used in safety. We can use them in new instruments. That's because we have an exemption from the EU. Obviously, lead is on the RoHS list, and we had an exemption for using lead sensors in new instruments up to now. In the last few years, we have been working on a very special project, and this special project was about providing a lead-free option, zero-bias, two-pin drop-in replacement for the leaded sensors. In January, we launched basically that product, and I am going to go through the technical specification, how the sensor works, some details. So the fact that it's a galvanic sensor, it means it's like the lead sensors uses lead as a fuel. Lead becomes lead oxides, and the oxidation of lead produces a current. Here, what we have done is we have replaced the lead with another metallic salt, and therefore it works on the same principle. So we have basically, again, we have a galvanic sensor using the same principles, the same type of driving electronics are going to be used to make this sensor drive. So that means that actually you can use the sensor in existing equipment. Of course, you need to look at certification and other things, but the existing circuitry used for the leaded sensors can be used for this new lead-free option. The proof of this is that actually our boards, we sell boards with sensors. We sell the same board, whether it's with the lead version or the lead-free version. So now we can look at different parameters that makes a sensor work. Another parameter is how quick is the sensor. Well, here you can see in purple, you can see the time T90 that we find for a leaded sensor. And in green, you've got the performance for the lead-free. So it's very comparable in actual fact. We can also look at the linearity. How linear is that? In actual fact, you can see here for lead sensor, here for lead-free sensor, we got the same type of curve. It's a logarithm. Why it is like this? Well, it's physics, really. It's control. This is a diffusion control through a small capillary. So basically, there is no reason, and the physics wouldn't work differently if we change the fuel. Another thing is we can look at, that's more interesting a bit, like, is the sensor lasting when you go through time? So we had to do extensive testing, of course, to get there. Many hundreds of sensors built, and many hundreds of different things trialed. But we are very confident that we have a sustained life with time with our new sensor. So another thing I want to say is, of course, galvanic sensors in the past were known to be leaking. We have at Alphasense introduced 3 years ago a leak-free version that had a great success. Basically, leaks, I think, for us, at least at Alphasense, is something of the past. And we were able to use here the same patented design for those sensors. So we are not expecting any leak for those sensors neither. Now, when it comes to use them in safety equipment, that's mainly our market. There is certification involved. Sometimes we talk about intrinsic safety. Here is some measurements here that we do to see open circuit different type of parameters to look at what type of current the sensor can generate and how safe is that. Well, it's very, very comparable again to what we get the leaded sensors or the lead-free sensor, very, very comparable parameters, which means that the certification, expert certification, is expected to be very straightforward. Now, maybe it's interesting to spend a few seconds just looking at an update on where the EU is about the ban of the lead. In actual fact, the EU is not that quick. Everybody will know that. And so an update every year is more than enough. In actual fact, here, what we have is leaded sensors at the moment can be used in new instruments. That's because of the exemption. And then what happens? Well, 4 years ago, Alphasense paid for a special study, and we did an application to get a further exemption that is going to last until the end of 26. We got that exemption at the time. It was granted up to January 27. For the ATEX product, up to July 27. What does it mean? It means that the EU now has paid some experts to look at the question, and the recommendation for the EU, to the EU now by this expert paid by the EU, and this is published, you can find it on the internet. The recommendation is that next year there will be a ban of lead oxygen sensors in new instruments. To be very precise, I am not expecting next year to have this ban put in place, because what happens is the EU would give a certain number of months, probably a year, of delay for people to comply once they have voted on the subject. So basically, we are basically all sort of dependent on how the EU is going through their process, and when they decide to vote on the subject. And then once they have voted, I believe there would be a delay of about 12 months before people would have to comply with the law. So, but the situation really still is that we don't expect a lot of exemptions anymore in the future. Experts have been very clear. There are now alternatives to leaded sensors. And so there is a sort of a view that we are going to get closer to a time where lead sensors will not be authorized for a new instrument anymore. This is different for any spares. So if you have instruments that are already in service, we believe that the EU will grant permission to use leaded sensors in those existing instruments, and there will be no time limit for this. Now, in making the EU being slow at implementing all of this, there was some groups, some people using LED sensor in some applications where they were finding that the alternative at the time were not suitable for their specific applications. I can make the point here really that now the sensors that we have brought to the market in January, there would be drop-in replacement. It means that basically there is less reason for the EU to wait. We have a completely RoHS compliant sensor that doesn't have any toxic component in it. So if I sort of summarize where we are, so we have a sensor which has the same physical dimension as leaded sensors. It is RoHS compliant. It's actually also REACH compliant. It doesn't have any toxic component in it. It has a leak-free guarantee. We can use it on the electronic board that already exists for leaded sensors. It has performance characteristics, 0 T90, output temperature, compensation, pressure transients, which are very, very comparable to existing sensors. It has, we at the moment give a two years lifetime guarantee. And we have the same concentration range, and it was available since January 26. So basically what I'm saying in all of that is that really we have what we call a drop-in replacement, something which you will not see very much the difference if you use it in your instrument. Of course, you need to deal with certification. That's a different topic. So what is the significance of all of this? Well, certainly for our company, for Alphasense, this is a big thing. We sell a lot of leaded sensors, so we have a lot of customers relying on us to service their instrument and for the future of their instruments. As it stands, it's very much Alphasense. The LED galvanic sensors were very much part of the identity of the company. This is how the company 30 years ago sort of started to grow. And so it feels today, when Alphasense is just 30 years old, that we are sort of renewing the product base of the company. So we believe that the product that we have introduced does serve the requirements for safety applications that we, mainly our market. So we are actually at a time now where, because there is already about 6 months that we have the sensors in the world. Actually, we have released sensors to trusted client before that. We have sensors in the field for a while now. We clearly have an overwhelming message coming from everybody in the field, and that is those sensors that we have made, the lead-free sensors, behave just like the leaded sensors. You will not see the difference. They are drop-in replacements. If we look precisely at, okay, what is the impact of bringing those sensors to the market? Certainly, we have to say that bias, amperometric sensors, minus 0.6 volt sensors exist already. We already have those sensors also in our catalog. Actually, I introduced one before City Technology at Alphasense quite a number of years ago. We have now a second generation one, which is probably, you know, very much more sophisticated and much more precise. In actual fact, galvanic sensors, they offer you, it's like a battery. So it's self-powered, it's a self-power. So it means you're not going to run down your battery. So for portability, that's quite important. Another thing, of course, also is that you don't have to keep the bias on the sensor. So what it means that when the sensor is off, what people do is they short the two pins together. So you got a FET in between the two pins, meaning the sensor is working all the time. You only need to connect the two pins for it to work. But it means when you switch on your instrument, well, the sensor is already working, so you don't have any time off. Your instrument is ready to read the oxygen concentration right away. So you don't have that trouble. It's particularly well suited for ATEX. It doesn't have like lots of platinum black catalyst like in the biosensor, or you know, that can generate some kind of fire. Or it's a very safe sensor. It has characteristics that are so comparable that I believe that ATEX wouldn't feel difficult to get them certified. Very same characteristics. In terms of the circuitry, well, you can reuse your existing circuitry, so you don't have to invest into redesigning your circuitry. Again, for certification, easier. And then it gives the flexibility on applications, because these are very resilient sensors. They are not affected by cross-sensitivities and other things. So really, when you look at it all, really, that's a summary. We have dealt with the question of leaks. We offer a leak-free sensor. We have now 3 years of record of selling a very great number of sensors in the entire world and not getting leaks. We use here the same design for those sensors. We have a RoHS-compliant, non-toxic sensor. And it gives a possibility, really, for our customers to get into a RoHS-compliant device with minimal effort. So that's it for me for today. Thank you very much. If somebody has questions, I'm happy to take questions. I'm happy to receive people afterwards as well. Great. Well, thank you again.